Okay, so I want to bring some closure to the Scrappy the Dog question and show you how you could have done it. And then I'm going to show you a shortcut that would help to do the problem. All right, so some things that we already had established yesterday is that he had gone 2 here, he had gone 1 here. The distances are important. If you don't have the distances, you can't just figure the stuff out all by the angles. That's not possible. You have to use these distances in your calculations. All right, next, we had figured out some angles. Help me out. What was this one again? 60? All right, can you verify that? All right, I want to just take one kid's word for it, or we can knock down a bad path pretty quickly. All right, then if that's alternate interiors with that, then that total is 60 down there. But we knew this was called northwest, and that meant that was a 45-degree angle right there. And if this and this together make 60, that was 15. Are you following me so far? All right. So now, because this 60 and this 60 go together, okay. Now, I have got a lot of info here, but I don't have everything that I could have yet. If this is 60, then how much is this bottom little corner here? What do they add up to? They have to add up to 60? That and that? What do they have to add up to? 90, and therefore it's 30. Okay, and then that makes a nice 30, 60, 90 triangle right here. Now, why is that important? Because that is a triangle where you have one side and one angle, and that's what I said to look for. Okay, next, we don't the triangle that we want is this guy, but it's not a right triangle, and so you can't use like I have one side and one angle. It doesn't work. But there are other triangles that we do have one side and one angle in. Here's another one. That guy, would you agree that in that guy we have one side and one angle? And therefore, using trig, we can find all the others. All right, now this takes a little bit of a leap. But do you get that there's another right triangle? I'll make it red. Right there. Now we don't have one side and one angle in it, but we will fairly soon. Why? Let me draw this better. Oh, he sees it. Yes, there is absolutely. I can make this square and I can make 2 triangles out of it. That would work. Yes, you can make a triangle right there. But there's even another way. And this is the way that we usually boil down to. And these problems can always be solved this way, by making the triangles that are around the outside. Do you get that my key triangle here, I'm going to shade it in blue. All the triangles we're dealing with right now are around the outside of it. You know, you've heard of the term working outside the box. That's what you have to do, is you have to go to all these other triangles that are outside of that one and use those to figure out stuff. All right, so one thing at a time. I'm going to call this H1. I'm going to call this H2. Do you agree that H1 is something we can figure out? Because it's in a triangle where we have an angle on the side. Do you get that H sub t, as in the height total, is made up of H1 plus H2? Do you get, therefore, we can figure out, how do we get this one? Because it's a 30, 60, 90, and we know a side. Okay, so we get this one, right? We know that one, and we know that one. If we know those two, do you get that we can get this one by just subtracting the big one minus the small one? All right, so basically you work around the outside of this thing to find all of the sides and the angles. Yes? This guy right here? Are you talking about this triangle again? Yes, you can absolutely do that. I know from past experience that you can always do the way I'm showing you right now. There's always a million ways you can do these. There's so many triangles running all over the place. And if you get a way that works, cool. I'm going to be fine with any way. I'm not the type of teacher that's like, I didn't show you that way, so I'm marking it wrong. As long as you show me your work and you get the right answer, I'll be fine. Okay, so is there any other situation that's kind of like that? You know, where the two heights add up to the big height? Go the other way. Do you see that there's this big length here? That total length? I'm going to call it LT, the length total, is made up of this guy, which we know. I'll call it L1. And this guy, which we can figure out because we know this length, because he's part of a triangle where we know an angle on a side, and this little part. And so this part plus this part has to equal this part. Okay. I know that's pretty intense. So now we need some time to actually crunch the numbers on this. And I want you to work with a partner. And I want you to figure out, first of all, I'd start with these sides right here and right here, because we know those. Those are in a part of a little 45, 45, 90 triangle. And once you know those parts, maybe you'll need to know these parts. Find this and find that. Do some subtraction, and then you'll know this, and you'll know this side. And then once you know that, you will know once you have two sides, and maybe that's something that you don't know. Once you have two sides in a triangle, in a right triangle, do you get that you can figure out everything from that? Let's talk about that for a minute. Here's a blow up of that top little triangle. Let's say I knew this was 3 and I knew this was 8, and this is a right angle. Actually, I can't just do that. Actually, I can. Yeah, I can make. I'm going to pick numbers, 3 and 8. Do you get then I can figure out what this angle is? Let's just take a second and try that one. Everybody just take this little side problem with that's 8, that's 3, and you're going to use sine, cosine, or tangent of theta, and you're going to need to do that inverse trig. Remember how to do that? I'm not giving you the right answer right now. Let's say I said sine of some angle is 1/2. Do you remember how to do that on a calculator? Because that's what you're going to have to do in a second here, is solve something like this. So how do you do this where you don't know the angle? Who knows the little function for this? Inverse sine. Does this ring a bell? This is when you did inverse sine, is when you're trying to solve and you've got two sides and you want to know the angle, you do inverse sine. Everybody do inverse sine of 1/2. Inverse sine cancels regular sine, and theta equals, and I just told you, I'm not doing the problem for you. You have to do this one yourself in a minute. But I just want to make sure you remember how to do inverse sine. That's how you get an angle. Use your calculator. You'll need a graphing calculator. It won't happen any other way. If you have your cell phone out right now, you're about to lose it. If it's in the crack between your iPad, I can see it in there. Put it away. Cell phone should not be out. You want to borrow a calculator? Give me some collateral. Cell phones work. Ever since I've been taking cell phones or keys to borrow my calculators, I've only lost one in a couple of years. Otherwise, I was averaging losing 3 a year. So I know it's annoying to have to leave me collateral, but at least I get my calculators back that way. Okay, so right now, did you figure out that this answer was 30? Raise your hand if you got 30 degrees. Okay, good. Then you remember how to use inverse sine. If you don't, you need to fix that right now. Talk to the kid next to you. If you're still sitting there without a calculator, please come up and borrow one. I will be on your back about that. You need to have a calculator out. Don't do it on your iPad. You won't have your iPad during the test. You'll have a graphic calculator. All right, Now, these two rows slide next to each other. These two rows slide next to each other. 6 inches apart. These two rows slide next to each other. First, do this. Make sure you know how to figure out that angle. Figure out theta. It's not 30. And satisfy yourself that everybody in your group knows how to do that. Then go back and do the Scrappy the Dog problem. Finish it off. Okay, just a quick review. This is how you would have found this one, and I hope you knew how to find inverse tan. Inverse tangent of 3/8 is how you find that angle, and you should have had 20.55 degrees for that one. If not, then you don't know how to use inverse, and you should come up and get a lesson. 20.55 degrees. If you got 0.35, you're in radians. You got to get into degrees. All right, so that's just a quick reminder how I do inverse trig to be able to find an angle. Now we're going to go back to that Scrappy problem. And by now, so let's get some numbers on the board. Who has figured out this big height on the left-hand side? Just tell me, and I can get it verified by somebody else. It's 1? Raise your hand if you agree it's 1. Okay, awesome. Then this side right here adds up to 1. That means the two smaller ones must be less than 1. Okay. Next, the one on the bottom. Oh, I'm starting to recognize this guy. 1, 2, and what would this one be? Square root of 3, also known as some decimal. You can use the decimal if you want to. All right. By the way, did anybody actually figure out what is square root of 3? 1.73-ish. Okay, good. Then these smaller ones will be important. All right, so let's tell me somebody has figured out this guy. 1 over root 2. And did you get a decimal for it? Yep. 1 over square root of 2 for this side, also known as point what? 7. I'm going to call it 0.71. All right. And then the other side has to be the same because that's that kind of a triangle. It is an isosceles triangle. This will have to also be 1 over square root of 2, also known as 0.7. I know this is getting really messy. But now, if the whole thing, 1.73, and this part is 0.7, then that means this is about 1. Who has figured out exactly what it was? It's close to 1, yes? I know it's going to be, no, this one, not the angled dotted one, this straight side. Okay, I would agree it is root 3 minus 1 over root 2. Did somebody actually get the decimal for that? Yes, sir. Can anybody verify 1.02 approximately with rounding error maybe? Okay, good. Cool. We're getting somewhere. Now, why is this so good? Because the dotted line was what we wanted in the first place. We wanted to figure out this dotted line here. And it's part of this triangle. So now, this has gotten so messy. Back out, just redraw this triangle alone. We just figured out this side was 1.02. And what was this side? It must be 1 minus 0.7, so like 0.3-ish. Did anybody use something more exact? 0.3, 0.29, thank you. And then I have two sides in a right triangle. That's the example I just showed you. So we can now figure out this angle. And now that's not the final answer. The final answer would be all of this, but for the top part's easy. This is just 90, and then how much more than 90 is really the question. And then you do inverse tangent on that puppy, and who came up with this little small angle right here? Who's got that angle? Anybody? This angle right here? Yes. 15. Anybody verify? 15.9. 15.95. Okay, good. So then, I'm going to put that here. So about 16 degrees. And now, if I take 90 plus that, which would be about 105.95 degrees, that's the true bearings to get from here to there. And how far is it? Because it said if he's more than 1 kilometer away. He sleeps in the doghouse tonight. Well, you can figure out this distance pretty easy now because you got one side and you got one angle. How far was he from home? The dotted line length. Yes. 1.06. All right. Was Scrappy more than a mile away? Or a kilometer away? Yes, he was. So therefore, he's going to sleep in the doghouse. Yes. Yes. Once you have two sides in a right triangle, you can do lots of things with, it can do there's a million ways you can solve that. A squared plus B squared equals C squared is definitely one of them. All right. That's a way that'll always work, but I did want to tell you a shortcut. Now, I'm not saying that this will be like make the problem into super easy, incredibly fast, but it's pretty slick. Here I have what I hope is pretty obviously not a right triangle, okay? And let's say that this side is 3 and that this side is 4. And if I put the angle right, I mean, I know some of you are thinking 3, 4, 5 makes a right triangle, but I'm making it not a 3, 4, 5. Maybe it's a 3, 4, 7. I mean, it's 3, 4 something. And that's the point, is this thing I'm about to show you can figure this out. If this, definitely more than 90, right? Let's say it's 110 degrees. Here's how you can figure out the other side in a triangle like that. And if you want to use this on your test, you can, and because it can be pretty handy. Do you get that the Scrappy the dog problem looked a lot like that? And it wasn't hard to figure out this angle right here. And if you have a side and an angle and another side, we call it side angle sandwich. SAS, yes, side angle side. All right, now, what can you do with this? You can do the law of cosines. You've heard of a squared plus b squared is equal to c squared, right? That works for right triangles. But this formula I'm about to tell you works for any triangle, including right triangles. It's a squared plus b squared minus this extra little factor, and that's all you really have to memorize, and then you'll have the law of cosines down. It can be used on the ACT test. Now, somebody might say, what, he told you that the law of cosines is on there? No, they're not going to make you do it that way. They can do it with the Scrappy the dog way, which was really hard and took a lot of time. But can you use other math on the ACT that they don't expect you to use? Yes, if you know formulas that they don't expect you to know, you can still use them. Minus 2ab, got to move this over to make room, cosine of c is equal to c squared. Again, you already knew this part. A squared plus b squared equals c squared. It's just this extra little factor here, minus 2ab cosine c. That's the law of cosines. Now, one thing you have to know about it is this angle, this c, needs to be the angle in that side angle sandwich. You don't just get to pick, like on the other one, on law of sines, you can pick any side to be anything. You can name them anything you want. But if you're going to use this formula, that c has to be, this is an angle, right? Cosine of an angle. That has to be this angle. So how would I do that in this triangle? Well, then I've got A and B, and I've got cosine of 110, and that'll give me c squared. When it's all done, it gives me c squared, which tells you when you get the answer, be careful. The answer needs to be square rooted to figure out what this little guy over here called c is. All right, I don't want to spend a ton of time on that, but a lot of times really bright kids are annoyed that we never told them this back when we were learning it. I'm not going to spend a ton of time explaining how to use it, but if you want to use it, it's pretty slick. So in this case, it would be 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of 110 is equal to c squared. And I don't know c. That's the point. Little c I don't know. Big C I know. Big C, that's terrible c. It looks like an E. Big C I know. But little c I don't know. And if I solve all of that and take the square root, that will be that other side. All right. Now, don't say I never told you, but I can't afford to spend a ton of time on it. Okay? All right. Now, the only thing new for today is the trig isn't all going to be flat laying on the ground like kind of triangles like this. It's going to be 3D because the real world has right triangles that are three-dimensional. Like, for instance, let's say you have a flagpole. Now, I have a way of doing this that works pretty well to give you that 3D perspective thing. Start by making one of those little compass rose things on the ground, so to speak, except at an angle. Now, anybody who's a good artist would tell you that that is not a great start for a base of a flag. Okay, but let's make a little more 3D-ish. Here's our flag. And if we wanted to make that base look a little more convincing that it's like 3D, do you get how if I stretch out the X a little bit, it makes it look a little more 3D-ish instead of making a plus sign on the ground? I'm starting to get a 3D feeling about this thing. Like if I wanted to say Iran, it was really high winds, and so I ran a line to the top of my flagpole to keep it from falling over in the strong winds. Do you get how I just made a right triangle in 3 dimensions? And then, what if I started realizing that that was still kind of blowing a little bit too much in one direction, so I ran another line up to the top, like that. Do you get the things on the bottom are supposed to be like north, south, east, west, and therefore that must be a 90-degree angle down there? You see, now I have 2 right triangles, and yet I could even have a triangle that runs between them, like that. And what are you looking for? Right triangles that have, where they have given you, what? One side. One side is not good enough. Okay, they've given you one side and one angle. All right, so now, if they just say, here's a drawing, of course, it doesn't give me anything. I can't do anything with it. But if I give you just one side in here, still not enough. What if I give you one side and one angle? Well, then I could figure out a ton of stuff. What if I gave you 2 sides? Yeah, 2 sides can work. Let me give you an example of that. Let's say I knew this side here was 8, and I knew this side here was 7. Do you get from those 2 sides, I can use trig and figure out how big that angle is? And therefore, all the other sides in the triangle, and see what I'm saying? If you wanted to, do you get from the scenario I just set up right there that I have a side angle sandwich, which is exactly what I just said you could use a squared plus b squared minus 2ab cosine c on? All right, and since it's a right triangle, and that's a 90, it's not as critical because I said it would work for anything, but if you're in this one, a squared plus b squared just equals c squared. You don't have to worry about that whole factor for when it's not 90. That formula I gave you works for any triangle, but you can understand why people don't teach. They teach this because it's so much easier. But that other formula would work for every triangle, including right triangles. Just got to throw in that extra factor. Who's got it memorized by now? 2ab cosine c equals c squared. Okay, good. All right, anyway, I'm letting you use that early this year. It's the first time I've done that, and that was just something I discussed with a colleague, and I thought, that's a good idea. I'll tell them. I'm not going to spend a whole day explaining it. And the kids who are really chomping at the bit to use that, you can use it. All right. So now, have I given you enough? Not really. I haven't given you enough, because I have nothing about the heights. I can get everything about the triangle that's laying on the ground. Okay, but let's say that I told you one more thing. Let's say I told you, I know that the rope that I started with, the red rope, I know that that red rope is 30 feet long. Now do you get, I have 2 sides in. this right triangle? And do you get two sides in a right triangle? Can tell me everything? Because you can get an angle from it, and then you'll have a side and an angle, which is the thing I said before. It would be so critical. Okay, that's the only thing for today, is saying, okay, now we got different kind of pictures. Pictures that some kids are going to have no problem with because you're great at spatial. You can see things in 3D and it's no big deal. And there's other kids that are terrible at that. Hint, if you didn't like geometry, if geometry was like your lowest math grade, then you probably aren't great at visualizing things in 3D or spatial. And this kind of problem will be harder for you. All right, let's finish this one. I want to know, assuming that these are all right triangles, okay, it's going to be too easy to figure out the height of the flagpole because you can just use a squared plus b squared equals c squared. I want to know what this angle is right there. I'm going to call that angle theta, the angle that the green rope makes with the ground. Work with your partner to figure it out. You can't just get it directly, because in that triangle right now, we only know one thing, and that's not enough. In the pink triangle here, we only know one side, not enough. So use the fact that you have other triangles to get more information and thus figure out what the green angle must be. I'm going to pause for a second until you figure that out. Okay. So hopefully you realized that you needed the height of the flagpole. How many of you did it that way by figuring out this height of the flagpole first? That was smart. What was it? 28.91? That's what I think I heard. Okay, awesome. Then I have two sides within a right triangle, and therefore I can figure out the angle. And I personally would think of this pink triangle then in terms of sine. No, because I don't have the hypotenuse, so it must be tangent. Tangent of the unknown angle is equal to, let's see, opposite, which would be the 28.91 over the, not hypotenuse, adjacent, 7. And therefore, I now have to do inverse tangent to solve this. Inverse tan takes out regular tan. Inverse tan on both sides. Therefore, inverse tangent all that. If that's what you did, what did you get for your angle? 76.4, what did I hear? 3, 4, how about 76 point something? Would we agree with that? Would you agree it's 76 point something? Okay, good. So I don't want to argue about rounding decimals because people can round them in a lot of different ways. It depends on what you rounded this to. What if somebody had a more accurate answer there than somebody else? So anyway, 76 point something degrees. All right, cool. So then that's 3D trig. I think you see 3D trig is the same as regular trig. It's just all about the picture and understanding like where the triangles are. Okay. And again, usually they don't give you enough right away. If you had one side and one angle right away, that'd be an R2 question, a really easy one. So look for how are they trying to get me to do this strange question. All right, so here's another strange question. I'm going to run through a quick reminder of one of the important kinds that you have to know. All right, I'm standing on a building, and we're ignoring my height here, and I am looking up at an angle of elevation of 30 degrees, and I see a plane way up here that's flying, and I'm just focused on, again, we're not being technical here, I'm going to say the head of the plane, the very front of the plane right up here, okay? And at that angle, I'm saying that's a 38-degree angle. And my question would be, if the building's height is x, then tell me the height of the plane in terms of x. Now I'll pause for a minute and let you digest that. I'm looking up at a plane from here, at an angle of elevation of 30 degrees, what's the height of the plane in terms of x? And you can also use one question. You can ask me one question. What's this? You can ask me one more thing. If you could ask me one more thing, what would you want to know? And you can't just say what's the answer to the question. Okay? So I want you to talk to your partner and maybe as a group a little bit. What's the one thing that would be really handy to know? And we could answer this question no problem. All right, given you cannot ask me what x is, what's something that you think, and you maybe your partners agreed, would be good to know? Yes? How far is the plane of the directional, right? So like the hypotenuse, so to speak, like that distance? And why would that be good? I'm not saying you're wrong, I'm just asking. Yes, the height. The question was, what's the height of the plane in terms of x? And by the way, what does in terms of x mean? So hold on, you're asking too many questions. What does the height of the plane in terms of x mean? Yes? Yes, the x will be included in what the height is. And yes, I did reiterate twice that I was standing on top of a building right there. Yes. And x is the height of the building. Okay, now, I will give you this number that you have asked for. Is there another number you could have asked for? Yes. But there's actually, it doesn't really matter much, because now I've got one side and one angle in my triangle. All right, so I'll say that this is exactly 1 mile. It's 1 mile to that plane, from you to the tip of the plane. I'll pause for a second, let me try that. Okay, I know that most of you are here by now, but there was a couple groups that aren't. So if you haven't figured this out, this is the key triangle. And really, all you got to figure out is this. I'm going to call it M. You can figure out M, you'll have it. You'll know the answer. Okay, so cut to the chase. This, angle of elevation 30. I hope you got that that was 30. And that makes this the classic 30, 60, 90 triangle. Now, I could do this in my head in using things like square root of 3 and 1 and 2. But I'd be fine with just using regular trig too. And let's go tangent. No, this time I have the hypotenuse. Ooh, that was weird. That's what tangent would look like if you wrote it in dotted lines. Now I got to delete them. Hold on a second here. Okay, I'm going to try that again. Tangent is not the right one. Dang it. Its sine of 30 is m over what? 1. So apparently m is sine of 30. Isn't that weird? So you could write this is sine of 30. Because this equation right here. Because m divided by 1 is m, right? And therefore, what's your answer? Sine of 30 is the height of the plane, except we got to remember to include the height of the building, because the height of the plane wouldn't be longer than sine of 30. It would be sine of 30 plus x. So sine of 30, if you want to actually calculate it, is 1/2. In the context of this question, it's 1/2 of a mile, because we gave the other answer in miles. So it's 1/2 mile plus x. Raise your hand if you had that one right. Awesome. That's just an example of how they can make it a little more obscure, but still boils down to right triangles. You know one side, you know one angle. After you've got that figured out, it's easy. Okay, so your homework for tonight. Let's find that file that says 3D Trig. Trig, I'm going to pause for a second. Blood spatter analysis. You guys have seen CSI, right? This actually can be used, and they did this for a while, but it's very difficult to make the blood spatters come out with angles that worked nice. But you can figure out from the width and the length of the blood spatter, there is a simple equation that they have figured out that can say what the angle was that that blood spatter came in at. So in other words, do you get, we'll do a really simple one, that a blood droplet that goes straight down would make a nice simple circle, and a blood droplet that came in at an angle would get stretched out. It wouldn't be a nice simple circle. You can figure out from that at what angle it came from. All right, tell I'm grossing some of you out, so I'll move on. So, getting close. All right. We might do these review problems as we get closer to reviewing for the test, but I'm not going to use them today. Now, this was their base of their little triangle. Remember me saying that if you're going to draw things in 3D, it's nice to have like a compass rose on the bottom, but not a plus-shaped one. Notice how this one's, again, kind of stretched out. I do recommend that for drawing them, because we're not going to draw it for you. You have to draw it yourself. So you take your straight up and down thing like your flagpole or whatever, and put its base into a stretched out X, and think of those as north, south, east, and west. I really don't care which you label as which. They could have gone with this was north, this was south. I mean, whatever feels right to you, it won't matter. It'll still work. Okay, so your homework. Pausing to get there. Okay, so I'd like to do these two problems. The one's called practice problems. This first one is kind of a Scrappy the Dog problem, where you got to draw your little compass roses. Don't forget to always draw those in. That one formula that some of you have memorized, don't think that's just going to save you from all the angle stuff. It'll help, but all right. So make sure that you have your compass roses as you do the first one here, and then I want you to also do this one. So basically, two challenging word problems. They're not impossible, but one's got that angle of elevation thing going. The other one's got bearings. Okay, that's your homework for tonight, and that's all I got for the video for today.